So now we come to know about what Kirchhoff's rule is about. Let's try and uh, apply Kirchhoff's law and solve the question. As you can see in the diagram, we have a circuit with 3 loops. Okay, so this is one loop. So this is one loop, this is second loop, and as you can see, this is the third loop, overall loop. Okay, so judging on these, using these 3 loops, we are going to find the value of we are going to calculate the value of current in the arm CF. Okay, from this position to this position. Okay, so for that, first thing we are going to do is we are going to find the value of current and how the current is going to travel. Okay, so using junction rule, we're going to find the direction of current. Okay, so for first current, let's say this is I. Okay, this current I is traveling through the circuit, and at junction A it is going to break down into 2 parts. Let's say this is I2. It is breaking at junction A into I2. That means this direction, the current in this direction is going to be I minus I2. Simple. So current I minus I2 is traveling up to this point. Okay, so I2 is traveling over here. Then again at junction C, I2 is going to break down into 2 parts. Let's say this is I3. So this current is going to be I2 minus I3. Okay, now I2 minus I3 that is traveling in this direction is going to meet I minus I2 at this point F junction. Okay, so the resultant is going to be I2 minus I3 plus I minus I2. So I2 is going to cancel, so current at this junction is going to be I minus I3. Current in this junction is going to be I3. There's no distribution over here, and when I add I3 with I minus I3, I'm going to get I over here. So as you can see, junction rule is being followed. As is evident over here, junction rule is conservation of charge. Okay, conservation of charge. So junction rule follows conservation of charge. Judging on that fact, so we came up to this conclusion, and from here we can see clearly the distribution of current throughout the network. Okay, so that is your first step, the direction of the current. Now next step, what we are going to do is we are going to use the loop, and then we are going to calculate certain current. Okay, and for the first loop, let's check out the loop of ACFEA. Okay, so first loop ACFEA. Okay, so as you can see clearly, this is the resistance, this is the resistance. So this is the loop of ACFEA. The current in this direction is I2. This direction is I2 minus I3. And this direction is I minus I2. Same over here, I minus I2. So for this loop, if you take it as, what do you call it, clockwise. Okay, so you can see the direction of the current and the direction of the loop is same. So for the first part over here there is going to be a drop, so minus I2 R. Okay, over here same thing happens. You can see the direction of the current and the direction of the loop is same. Okay, so negative I2 minus I3 within brackets with resistance R. Now as we move further down, these two portions, the direction of the current and the loop is opposite, so plus I minus I2 R plus I minus I2 R. This is equal to 0. So this is your first loop. Okay, similarly for the second loop is going to be CDFB. Okay, CDBFC. I3 current I3 I minus I3, and same over here it is I2 minus I3. Okay, so depending on the question, sometimes you're going to get the direction of current, sometimes you have to construct it yourself. Okay, so for the second loop, again let's take it clockwise, anti-clockwise, any direction you like. Let's take anti-clockwise. Okay, so for current in this direction, the direction is this way. Okay, this is the direction of the current and this is the direction of the loop, which is anti-clockwise. So these two are opposite directions, so we're going to get plus I3R. Similarly for this direction, I3 and the loop direction is opposite, plus I3R. So these two portions are done. Now this one, it is in same direction, this is also in same direction, so negative I2 minus I3R, and same thing over here, minus I minus I3 R equals to 0. Okay, so in that way we are going to get two equations. Now the variables over here is I1, I2, I3, three equations. So that means three variables, that means three equations are required. R value is given, which is how much? 5 ohm. Okay, we can substitute 5 ohm easily and get the value. Alright, so this is first equation. Second equation, you can simplify the first equation as well. Okay, and then second equation as well. Simple. So this is your first step. Now third step. For third step, you're going to take this loop. Okay, so I'll take this loop and we'll see what happens. Okay, so this loop is like this. First resistance, second resistance, third resistance, and then goes out. Okay, depending on resistances, we have got current I minus I2. This is also I minus I2. For the third resistance is I minus I3. And last we have I and input I. Okay, so the current and the resistance in this portion, current and resistance in this portion, this is what the diagram is. Okay, I have simplified the diagram slightly. Okay, and likewise you have current. So that being done, now let's take it as clockwise. Okay, so the battery's voltage is 15 volt. Okay, so when we are taking it clockwise, what is happening? It is going from negative to positive. That means gain. So positive 15 volt. Okay, as we move further up, you can see I minus I2 and R. This is generally the direction of the current in each case. Okay, so the current direction and the loop direction are same, so this is going to be negative R I minus I2. Same with that, negative R I minus I2. And last one, same direction of current and the loop, negative R I minus I3. This is going to be equal to 0. So what we have is first equation, second equation, third equation. Okay, now this I is going to get cancelled. So do you know? So we have variable I, I2 and I3, three variables. And same way we have first equation, second equation and third equation, three equations. Okay, and using these three equations we can find the value of I1, I2 and I3. There's no I1 variable over here. Okay, so these three variables can be found, and then what needs to be found is the current in the arm CF. This junction is CF. Okay, so the current in CF junction is I2 minus I3. So after finding the value of I, I2 and I3, you can easily find the value of I2 and I3, I2 minus I3. Okay, simple. In that way we can find the values. Simple.